Welcome friend. Again we have to discuss our subject several variable calculus. In the previous lecture we solved some problems on local maximum and minimum value. Here we use the first derivative test, second derivative test, and we find critical point and then we check at each and every point it is local maximum, minimum or saddle point, and then we put this value, it is in a function and we get a local maximum or minimum value. Now in today's lecture we have to solve some extra problems or theory problems on local maximum and minimum. So we take some extra or theory problems on local maximum and minimum. So we will go for our problem number 1. So we solve first problem. What is our first problem? Find the shortest distance from the point 1, 0, minus 2 to the plane x plus 2y plus z is equal to 4. Here is a 2. Here is a 2, not a z. Okay. So what is given or what we have given? We have to find shortest distance, and for this we have to use the distance formula. So what we write? The distance from the point x, y, z to the point 1, 0, minus 2 is. So what is our distance formula? D is equal to, distance formula, D is equal to square root of, what is your formula? D is equal to square root of x minus x0 square plus y minus y0 square plus z minus z0 square. So what is our x0, y0, z0? This is x0, this is y0 and this is z0. So what should be the answer? Answer should be what? X minus 1 square plus y minus 0 square plus z minus plus 2 square. And therefore what we are getting, your D, or what should be our D square? It is equal to what? X minus 1 square plus y square plus z plus 2 square. Okay, but what we have given, one more, we have given also a plane. We have given a plane. If this point x, y, z is on the plane, which plane it is? X plus 2y plus z is equal to 4. Then what we can put? So put z is equal to 4 minus x minus 2y in equation 1. So you have to put this value in equation 1. So this is our d square, and we can say it is now a function of two variable because z is removed. It is equal to x minus 1 square plus y square plus, here should be what? Here should be what? 4 minus x minus 2y plus 2 bracket square. So what we can write? Our f of xy is equal to x minus 1 square plus y square plus, here just do calculation, this is what we can write here? 2, 4, 6 minus x minus 2y bracket square. Say this is equation number 2. And now this is our function of two variable. It is function of 3 variable, but for this we have given a point. So we are finding this point, this function, it is of a 2 variable. Now you have to find the shortest distance, and for this we must use the second and first derivative test. Now what we have to find here? Now we have to find the derivative of this function. So what is the derivative? what we have to find first? Fx at xy. So it should be what? X square. So it is 2 into x minus 1 into derivative of x minus 1 is 1. So no problem. It is 0 plus again it is a square. So you have to use again chain rule first. Here is 6 minus x minus 2y and into what? Derivative of 6 minus this is our minus 1. This is our, so our fx at xy is equal to 2x minus 2 plus, here just do calculation, it should be minus 12 minus minus getting plus, here is a 2 minus plus 2x, again minus minus plus 4y. Now do simplification here. Here is what? 2x, it is 4x and it should be what? It should be, you can write here, it should be what? Plus 4y minus 14. So this is fx at xy. Now what we have to find? We have to find fy at xy. So what is your fy at xy? Derivative of this term is 0 plus here is what? 2y plus here is what? 2 into 6 minus x minus 2y into derivative of this is 0, 0, here is minus 2. Just try to solve this. What you are getting? 2y plus, and here minus plus is here, it is a minus 12. 6 2s are 12, 2s are 24. Here is a 2 minus 2x minus plus 4x plus here 2 2s are 4 2s are 8y, and what should be your answer? It is 8 what? 4x minus 10y plus 10y and plus minus 24. This is our fy at xy. Okay. Now what we have to take xx is equal to 0 and fy is equal to 0 for finding critical point. So what we are getting? 4x plus 4y minus 14 is equal to 0 and 4x plus 10y minus 24, it is equal to 0. Now just do subtraction. What we are getting? 4x plus 10y minus 24 is equal to 0. 4x plus 4y minus 14 is equal to 0. Just do subtraction here. So what should be the answer? What should be the answer here? This 0. This is what you are getting here. Minus plus 6y, and here is what? 10 minus how much here? 10. It is equal to 0. Therefore y is equal to 10 upon 6 and it should be 5 by 3. So our point is 5 by 3. Y is 5 by 3. Put this in any of this equation. So 4x plus 4 into 5 by 3 minus 14 is equal to 0. And what we are getting? 4x plus 5, 4 5s are how much? 4 5s are 20 upon 3 minus 14 is equal to 0. So do calculation. 4x is equal to what we are getting? 4x, it is equal to 14 minus 20 minus 14 minus 20 by 3, and it should be 14 3s are 28, 42, 42 minus 20 upon 3, and it should be what? How much it should be? Equal to 22 by 3, and here 4x is equal to 22 by 3. Therefore x is equal to 22 by 4 3s are 12. So x is equal to 11 by 6 you can write. Then what is your critical point you are getting? You are getting a critical point. What critical point now? This is our function is important, so I am not erasing this. So what we have to get? Thus the critical point is what? What is our critical point? It is 11 by 6 and 5 by 3. And now what we have to use? We have to find the shortest distance, that is you have to check the here it is a minimum or maximum. So for this what we can find here, fxx, we now must find fxx. Fxx is equal to what? This is our fx, so fxx it should be 4. So and fyy is equal to, fyy it is equal to what? It should be 10 only. And then what we can write, fxy, what should be our fxy? Fxy is again a 4. Okay, so now we write fxx at 11/6, 5/3, it is constant, so not a change. Fyy at 11/6, 5/3, it is equal to again a no change, and here fxy 11/6, 5/3, it is again a 4, no change because not a x and y. So now what we can find, d are at point 11/6, 5/3. By the second derivative test we have to use, so it is fxx at 11/6, 5/3, fyy at 11/6, 5/3, minus what? It is fxy 11/6, 5/3 raised to what? Raised to 2. And put the values now. Fxx is what? 4 into fyy is 10 minus here is a 4 square, and it is what? 40 minus how much? 16, and it should be what? It should be 40 minus 16 is 24. This implies that d at 11/6, 5/3, it is equal to 24, and fxx at 11/6 and 5/3, it is equal to what? 4. It is again greater than 0. Therefore what we can write? By second derivative test. Second derivative test. What should be this? By the second derivative test, 11/6, 5/3 is local, what is a local minimum or maximum? It should be maximum or minimum. It is greater than, therefore it is minimum, local minimum. And now we have to find the shortest distance. We find a shortest distance How we find the shortest distance? Our shortest distance formula, you can find first z. Z is equal to 4 minus 2y minus x, and it is equal to 4 minus 2y, 2 into 5/3 minus our what? X is 11/6, and it is equal to 4 minus 10/3 minus 11. You are getting here what? It is z is equal to what? Here 6 4s are 24 minus 2s are, then it is a 20 minus 11 upon what? 6. It is equal to how much you are getting now here? Now we are getting here minus 24 minus here 4 minus 11. 4 minus 11 is our 7 minus, or here is a minus 7/6. So our distance, you can find the distance. D is equal to square root of what? X minus x0, that is our x minus 1 square plus y minus 0 square plus z minus plus 2 square, and just put the values here. What is the x? X is what? X is our 11/6 minus what? 1 square, plus here y is what? Our 5/3 bracket square, and z minus 7/6 plus 2 square. and just do simplification, you will get the answer. So what should be the answer? D is equal to square root of, it is what, 611 minus 6 upon 2 square plus 5 by 3 square plus here minus 7 plus 6 to the 12 upon 6 bracket square. It is equal to what you are getting? It is 5 by 6 square plus 5 by 3 square plus what we are getting here? Again 5 by 6 bracket square. And if you did do the calculation, so what you are getting? You are getting your required answer. Do calculation this, 5 by 6 into square root of 6. This is your distance, units. You can write it is units. Therefore, the required distance is 5 by 6 square root of 6 units. Okay. In the similar way, you can solve the so many problems. So we will go for the second problem now. Okay, so we solve the second problem. So what is the solution? So what is problem? A rectangular box without a lid is to be made from the 12 centimeter square of a cardboard. 12 meter square means it is a area is given, area of cardboard. Find the local maximum and minimum of the such a box. Okay, so what we have to find? We have to find the volume. Okay, so what we can say, suppose let x, y, z be the length, width and what, height of the box respectively. It is respectively. Therefore what, volume of the box is equal to what, LBH, that is x, y, z. Say this is equation number 1. Length into breadth into height, volume. Now what we have to put? We have to convert this equation, it is into the 2 variable function. It is 3 variable function. Now we have to convert it is into the 3 variable, and for this they are giving one more thing, that is the area. What we have given? Rectangular box without a lid is to made from the 12 meter square. That is, there is not a lid, that is the upper surface is not considered and area is given. So we convert V into 2 variable function by considering the area of a box without lid. 2xz plus 2yz plus xy, it is equal to 12. It is equal to 12. So you can draw a box like this, rectangular box. Suppose this is your rectangular box, you can draw like this. And suppose you can take here LBH, x is a length, y is a breadth, so it is our x, it is our you can take here y, and it is our what, z, it is our z. So zx, 2 times zx, this and 2 times xy, this and xy is 1 time only because upper is not we are considering, and 2 times yz because these 2 areas. These are the two, and upper is not considered, only base is a xy. This area is equal to 12. So solve this for z. So 2x, you can take here z common, 2x plus 2y plus xy is equal to 12, and therefore you can write here, that is z is equal to 12 minus xy upon 2x plus 2y, and put this value, put value of z in the equation 1. 1. Then what we are getting here? V is equal to xy into value of z 12 minus xy upon what? 2x plus 2y. And now you can solve this. Therefore v is equal to 12xy minus x square y square upon 2x plus 2y. This is our function of two variable. Now this v you can take, v is a function of only xy. So this is our two variable function. Now you can use the first derivative text. So you can take vx you can write, or you can write here dA v by dA x. It is equal to, find this, it is 2x plus 2y into derivative of 12xy with respect to x is 12y minus here is 2xy square upon in minus what you can write here, this term is constant, minus x square y square into, there is only 2 plus 0 upon 2 into 2x plus 2y bracket square, 2x plus 2y bracket square. It is, if after simplification we are getting y square into 12 minus 2xy minus x square upon 2x plus y. This is equation number 3. Again we have to find dA v by dA y. Again you have to use here quotient rule. 2x plus 2y into what? Again you have to differentiate with respect to y. 12x minus 2x square y minus is what? 12xy minus x square into y square into derivative of this is 0 plus 2, and upon you can write 2x plus y bracket square. So what we are getting again after simplification, you will get the, okay. So if we take x is equal to 0 and y is equal to 0, this x is equal to 0, y is equal to 0, then what we are getting? V is equal to 0. That is volume is 0. So we are not able to take this, both are 0. For this what we consider? Then consider the two statement, that is the 12 minus 2xy minus x square is equal to 0 and 12 minus 2xy minus y square is equal to 0. What we are getting here? X square is equal to 12 minus 2xy, okay, and this implies that if you put this value in equation second, then what we are getting? X square minus y square is equal to 0 and it is equal to x square is equal to y square, and therefore we can write y is equal to plus minus x. Y is equal to what we are getting? Plus minus x. We take only positive dimension, hence x with our y is equal to x, therefore we have a y is equal to x, and then what we are getting? 12 minus 2xy minus x square is equal to 0, and here 12 minus x square, what you can write? 2x square minus x square is equal to 0, and here you are getting answer, that is the 12 minus 3x square is equal to 0, therefore x square is equal to 12 by 3 and it is 4, therefore our x is equal to 2 and y is equal to 2. You are getting x is equal to 2, y is equal to 2, and then you can find then our z is equal to, put this value x and y, it is in our z. What is our z? Z should be this. So this is nothing but 12 minus 2 into 2 upon 2 into 2 plus 2 into 2. It should be what? 12 minus 4 upon 8, and it is equal to what? 8 by 8, it should be 1. So we are getting our xyz. We are getting our xyz. So we get x is equal to y is equal to 2 and z is equal to 1 dimension. So what we do here we can say that take Vx is equal to 0 and Vy is equal to 0. That is first derivative test we use. Then we take 0 and then we solve this, and by the second derivative test we can show this point xy is equal to 2 is local maximum, or what we have to find maximum by using second derivative test. This is homework for you. This is homework for you. And now try to find the volume. Which volume? Maximum volume. So how we find this? Our volume is equal to, what is our formula? Just put the values here. Iz, it is equal to 2 into 2 into 1, and it is our 2 2s are 4. What you are given? Meter cube. So required volume of the box is 4 meter cube, and this is our answer. So in the similar way you can solve so many problems. So just use the first derivative, second derivative test, and you can solve so many problems. So this is also very important problem. So today we will stop. Thank you.